Hey, what's up? This is Jake from Nimbus DevOps, and we're going to talk about section 1.7, which is how Python code is organized. So I've got some repos, and I created a virtual environment called my app. And so inside of here, I've got my little scripts folder, and I can go ahead and activate this. Activate. All right, cool. And now we're inside. And the first thing I want to do is kind of talk about if we list the directories and files in here, we can see I've got this example directory, I've got this include directory, a lib directory scripts, and then this config file, but you can't see what's inside of it. So one of the things you can do is to do a tree, and it'll list literally everything inside and have a little visualization as to how it's set up. Now there's a lot of stuff in here, right? So what you might want to do is just do like example. So this example directory, I've got, you can see here on the side, if you're not using VS Code and you just have a terminal open, you can see exactly how this is structured and what's in here. And the nice thing about that is because when you're looking at how a library is set up and what's inside of it and how this app actually runs, using tree can kind of help give you an idea of how somebody, whoever wrote this, how they organized it. Okay, so we're going to talk a little bit about this stuff. We got into a little bit before, but I'm going to explain what this is here. So I'm going to go ahead and clear this and just have this up top. So in this example directory, I have a core.py file, which we know is a Python file, a run file, and a util directory. And inside of there, I've got some files that do database, math, and network stuff, and then this weird init thing down here. So what is going on here? Well, how this works is when you're running code, you can call other code from different places and import it as a way of doing a shortcut, right? So like in my previous video, I did an example with Excel. Instead of going, cell A plus B plus C plus D plus E divided by 5 is the average, you can just say equals AVG, pick the numbers, hit enter, and Excel knows what AVG is, right? But you didn't make that AVG thing, it just existed already. So in the same way, you can create things that exist already and then reuse them to make your code much shorter. And we do that by creating what's called a package. So this util directory is a package. And Python knows it is a package because we have this file right here. And it's an underscore underscore init underscore underscore .py. So if Python sees a directory and it has this in it, it recognizes it as a package. And then if I'm running other scripts or running my application up here or whatever, and I import some package from a library, then it knows like, oh, I can look here and go find that. So let's talk about libraries for a second. So a library is just basically this. It's like a package, right? And inside of that library, you have different modules. And each one of these modules does something unique. So maybe this does a database connection. Maybe this does a couple custom math formulas. And then maybe this one does some custom network scripting. And instead of having to write that, if you use this 3 times in one script, instead of writing it 3 times, you can just call it, much like you would use shortcuts in Excel, like average, sum, index, VLOOKUP, stuff like that. So that's just the basics of how this works, but essentially the whole purpose of this is just making it reusable. And you don't want to repeat the same piece of code more than once in your application. So once we get into coding, you're going to start with some basics, but because we went over all this other stuff first, we're kind of learning Python inside out. And this will kind of make you ask questions when you look at your code and go, hey, I noticed we did this twice. Is there a way to make this faster? And I think that's a good thing. So when I first started this first chapter in this book, I was like, I don't really see why we're starting with learning all these things, but I do think there might be some advantages to it, and I've never tried it this way. So we're going to give it the benefit of the doubt and just go from there. But there's, when it comes to reusability, there's several reasons why you want to repeat the same logic. using this methodology, using packages, libraries, stuff like that. And that's that you don't want to, like, let's say there's a bug in your code, right? If you were not using libraries and functions and you use that same thing like 4 times and it was wrong, you'd have to go fix it in all 4 places. And if you had lots and lots and lots of lines of code, you'd also have to go find it in all 4 places. Um, Whereas if you do it this way, you fix it once, and then when you fix it in this one place right here, every time you run this file and it calls math, um, it's going to do this every single time. So it just gives you one place to fix everything. You also might want to just change how you do things. So maybe it's not broken, but you want to add a feature to it, and you want to add another formula. You want to whatever you want to do. You can do that also very easily. You could also kind of forget how logic works because you missed it when you're looking for it, and you might forget to fix something. So it's kind of nice. Like I said, it's one of those things where if it's broken in one place, it's broken everywhere. But then if you fix it in one place, it's fixed everywhere. So there's a upside and a downside of that. And then, of course, probably the most important reason for end users is your code isn't longer than it needs to be for really any good reason, and so it should be faster. And for developers that are reading your code, it makes it much easier and more, as we say, elegant. So now I guess since I've used this word a couple times, we kind of want to break down what is a function. So up to this part, if we review, we've gone over, like, you have an app, and you use apps all the time, and you probably know what an app is. But an app is basically just a program, and in that program, you have these files, right? And each of these files are a module. And inside of this folder that I have right here, this directory, I've got a module and a module, and then I have this package, which is another way of looking at a library. And inside of that library, I've got these little modules here. Well, there's another way to explain this, and it's through explanation of functions. So Python has a lot of libraries, okay? And a library is really just a collection of functions and objects. So if we go down another layer, now we're talking about functions and objects. And so with functions, it's really just a short way to, let's see, it's like a little tiny file that holds code, a little bit of code that you can use that has a name and you can call it every single time, right? So like in the Excel example, average is a function. Sum is a function. And even those are all called Excel functions. So you've probably been using functions and you know that it does something, but you're not quite sure exactly what it does, but like at the lowest level, but you get the idea. Like average is numbers. You don't know exactly what it's doing, but you know that it averages numbers. So a library would just be a collection of those functions. So Python has its own collection of functions, its own library, and it actually has many libraries. So it has many collections of functions. And we can check this out here now if I go into a terminal. So if I just type Python, and we're in an interactive shell here, we can see our prompt. And let's say I want to do, and I'll explain it up here. We want to do 5 factorial. Okay, so written mathematically, that would be 5 exclamation point, or as you'll hear me call this, bang. 5 bang. So what does that mean? Well, in math, that means 1 times 2 times 3 times 4 times 5. It just takes the number and multiplies every number between this number and 1, including this number. And then you have to figure out what that is. So you could go, okay, well, what's 1 times 2 times 3 times 4 times 5? And Python would be happy to help you figure that out. Well, that's kind of a longer way of doing this, right? So there should be an easier way to do this, and there is. And instead of having to type all of this all the time, you can import the factorial function from the math library, and just say factorial 5, and it'll tell you what it is. So let's try that. So I'm going to say from the math library, import factorial, and then I can say factorial and in parentheses 5, and it just tells me. And the nice thing about this is, if I did the factorial of 123, I would have to go 1 times 2 times, and that would take forever, right? But in this case, I don't have to do that. I can just say, what's the factorial of 123? And it'll just tell you. So this is much, 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 much faster. It's much, much more user-friendly, and it's easier to read. You know, oh, it's factorial. So if I were writing a script like this, it would just look like from math import factorial, and then I would just say factorial of x, whatever number you want to give me. I could be like, hey, give me a number, right? Input, you know, enter a number or something like that. And I could set this as x. So then I could say from the math library, import factorial, and then I'm going to set a variable x and say, hey, user person, like you maybe, enter a number, and then you're going to enter a number, and then it's going to just say factorial x, and I could even say print factorial x, right? Or I could be like answer, if I want to get real technical, the answer equals the factorial of x, and then I could say print the answer. So you don't really know anything about coding yet, but you could probably look at this and get the idea if you just understand that all we're doing here is basic algebra. I'm just saying, hey, this is a variable x, and x is equal to whatever number you put. And then there's a variable answer, and that answer is equal to the factorial of whatever that number is. And then I want to print, or spit out, enter right here, whatever answer is. So essentially using this function factorial just saved us a bunch of time, because if the user enters 1, 2, or 123, this code doesn't change. So it's reusable, it's succinct, it's short, it's easy to read, it's elegant, it's very, very simple. And there's a million different ways to do this too. Some people might be like, that's dumb, don't do it that way. Whatever, this is just a simple example. So hopefully that explains a little bit more about the structure of Python code as we use it with modules, packages, libraries, functions. We already talked about objects before, so it could even have uh, an object in here, like these are objects. So if I wanted to save this file, this is core.py, this just became a module, right? It's a Python module. I could save this as a function and then rerun this somewhere else and say, hey, run core. And if you say, hey, Python, do core, it's just going to do these things. It's going to ask you for a number and return the factorial. When you'll be like, well, what? And you're like, yeah, that's what core does. So that might be a little confusing, but I hope not. This is the danger of trying to explain Python inside out, is that you don't know any of these things yet. So I'm literally writing this in Python code. You're looking at Python code. And if you understand this, then that means you're already on your way to understanding how this stuff works. And it's going to get more and more it's going to get much more complicated, trust me. But we're going to try to keep it simple and go in bite-sized portions, so that even the complicated stuff will just do, if the more complicated it is, the smaller the piece I'll do, and allow you to kind of just digest that. Now, if you get this the first time I explain it and you just want to go to the next video, hey, good for you. But some people, even after I explain it like 3 different ways, still have questions. So just know that this is kind of for everybody. And if you feel like this is moving too slow, then that means that you're ready for the next step, and that's awesome. So, hey, good on you, and keep trucking. So if you have any questions, let me know. But if not, that is just a quick overview on how to organize Python code.